Okay, here's our next problem. We're going to use our definition to prove that this limit is 9. So we'll start with this x squared minus 9 less than epsilon. Start with that, and that's from our form, from our limit, or from our definition. That's this part of the definition. Okay, now we're going to try to work with that and try to arrive at some kind of a restriction that's that we can place on x minus 3. So here we go. So let's try this. Let's break it apart like so. And that means that this would have to be true. Okay. Now, so we need to know how big is this thing here. So what we'll do is we'll start with, okay, so here we are. We need this, you have to find this, we need a limit on this. So what we're gonna do is this, remember, we're at 3 over here. And what we're gonna do is we're gonna start off by saying, well, let's choose a delta equal to a 1. And we'll adjust that if we need to. That's the idea. So here's my delta equal to 1. And that means that x is in here. Okay, which also means that x plus 3 is in here. So now that means that 1 over 5 less than, okay, so this becomes our this gives us a limit or a bound on the 1 over x plus 3. What I want is to find something smaller than 1 over x plus 3. So notice I can also put this in here. And now, since x is positive, it's between 2 and 4, we can put our bars on here. So now, if I pick epsilon, delta equal to epsilon over 7, and in my inequality over here, that will automatically imply this. Okay, so I'll have this. Which would then imply this, since epsilon. Okay, so that's what I'm gonna do. I'm gonna pick this because it's less than the epsilon over x plus 3, which would then algebraically imply I could go backwards to this statement if I'm at this statement. Okay, I can go backwards to this one because this would be less than the epsilon over x plus 3. So that's why I'm choosing it, because that'll be part of my proof, my statements. So now, I have 2 conditions. I have this and this. I chose delta epsilon over 7. Now, it has to be, both of these have to fit. So by stating that I'm picking the minimum of them, then that'll mean that they're both true. So then we have, as long as we've got our one of these to be true, I need both of these to be true. So in order to get that, I'll say that my delta needs to be the minimum of these 2. Okay, so that implies that I'll have the smaller of the 2. So now you can always pick a delta smaller than both of these if you really want, but I'm picking delta to be as large as possible and still have my proof. So now here's the proof. You have to start off and you can say, I'm going to begin with this. Okay, and I'm going to say to start with 1. So here, This is assuming that the 1 is less than epsilon over 7. So for some reason, somebody chooses an epsilon bigger than 7, then I would choose my delta to be a 1. Okay, so if epsilon were bigger than a 7, then I would pick my delta to be a 1. That would imply this. Now, having an epsilon bigger than 7 simply means that this statement up here is somewhat not quite as strict or constraining as a smaller value of epsilon. So it's saying that the difference here, the function minus the L, f of x minus L, has to be less than, it creates a band that is half of which is this 7, the different distance from the 9, that's 7. So this is my choice right now. So I'm assuming that the 1 is less than epsilon over 7. So that brings us to this. And I'm going to multiply by the x plus 3. So I'll have this. That. Now, this is a positive number. And if you look over here, you'll see we have this statement. Okay. Because delta is 1, that's smaller of the two. We have x plus 3 is less than 7. So that means that this statement down here is less than 7. Okay, so we have x squared minus 9 less than 7. Well, it still doesn't say anything about epsilon, but if you look at this, our first assumption was that delta was less than epsilon over 7. So that if you multiply by 7 here, you'll see this. So that leads us to this, which then leads us to this, which is what we want. We now have stated that this statement implies this one. So if I have this, then I have this. Okay. All right. Now, the other part of this proof is you can now assume epsilon over 7 is less than 1. Then if you begin with this, and let's try to get back to our form again. We'll multiply by the x plus 3. Epsilon over 7 times the x plus 3. And again, we have that x plus 3 is less than 7. Okay, so this is less than epsilon over 7 times 7, which is epsilon. So we have this statement, which is what we wanted. So this statement here now implies this one also. So that's how you finish the proof.